Isotope. This is an atom of an element. That has the same atomic number, but different mass number. So what responsibility for isotope is that there is a tendency of some element to have more than one different neutron number. Like I told us the last time, if you look at some element, they have more than one neutron number. So let's say you have chlorine, for example, now, e.g., we have chlorine 37, 17, chlorine 35, 17, then chlorine 37, 17. So chlorine exists in this form. And then also we have oxygen. 16, 8, then oxygen 17, 8, and then we have oxygen 16, 8, 17, 8. Then we have carbon. We have oxygen 68, 18, 8. And likewise we have carbon 12, 6, and then carbon 13, 6. So what do you notice about them? Let's look at this chlorine, for example. Now you can see if you say chlorine 35, 17. Here you can say atomic number of proton here is 17. How do you know the number of neutrons? So the neutron number will be mass number minus atomic number, that is proton number, that is 35 minus 17. So that means it's having a neutron number of 18. If you look at the one of 35 and 37, so neutron number there will be 37 minus 17. That means it's having neutron, proton can exist. You can have a neutron number of 18 and 20. Likewise, these two. So there's a slight varying number of neutrons of an element. So because of this, when an element is having two or more different neutron number, that element we explain what we refer to as isotope. And this one, what we notice about this? For an element to have two or more different mass number, it shows that they still have the same chemical properties, but only different physical properties. For example, for this chlorine now, we can say they behave chemically the same. The only difference there is physically, like chlorine 35. This one might be soluble, this one might not be soluble. This one might be slightly high boiling point, and that's how physical properties you can notice about them when they undergo isotope. But chemically, they behave the same. What determines the chemical properties of any substance is atomic number. Atomic number determines the way they will behave chemically. Why the way they will appear physically is their mass number. Mass number is telling us about their physical properties. Whether they are soluble, they are heavy, density, insoluble, color change. So mass number is responsible for that. But the way they behave chemically, atomic number is responsible for that. So because of this, we can say that elements undergo isotope. They have the same atomic number but different mass number. And this one will now make us look at how can we now get relative atomic number. Relative relative atomic mass of an element. Because there are some elements that with the way we appear, they have different varying mass number. We can get their average. That means average mass number, and that one has to do with relative atomic number of an element. So we can use that there because they undergo isotope. So there is need for us to get their average of their mass number. So we can get that one by getting their relative atomic mass. So to get relative atomic mass of element, so you can obtain that using relative atomic mass can be obtained using carbon-12 scale. Using carbon-12 scale. When you say using carbon-12 scale, means we are using carbon as our reference, mass of carbon as our reference point in determining what the mass of other elements. That is what we refer to as using carbon-12 scale. And how do we now obtain that? To get our relative atomic mass, we need to measure the mass of element in relative with to obtain the average mass. So we measure the mass of each element to now get the relative mass. That is what we mean by what? Getting the relative atomic mass. Let's look at relative molecular mass now. Relative molecular mass. So for relative molecular mass, so we can see this is the sum of relative atomic masses of elements that make up the molecules of oxygen that make up the molecule of a substance. Just like I told us that relative atomic mass of an element is getting the average mass of that particular element. If you now want to get a relative molecular mass now, if you have a molecule, let's say a molecule of sugar now, let's say glucose. Glucose is C6H12O6. This is a glucose. And you want to get, this is a molecule of glucose. You want to get relative molecular mass of this. So each of them have an atom. You are going to add what? Atomic mass of each of what? Element or atom you can find in this glucose together. And that will be like what? Relative molecular mass. So we can get molecular mass by getting what? Adding each atomic mass, atomic weight of each atom made up of that substance, made up of that compound, add them together. It will give you relative molecular mass. So molecular mass, you get it from adding relative atomic mass of a particular element in a compound. So let us now see let's just look at example. How can we find a relative molecular mass of a particular element? So let's see how we can get relative molecular mass of some element. So let's look at the e.g. calculate the relative calculate the relative molecular mass of the following compound. Let's see how we can calculate molecular mass of the following compound. 1, you have let's say Na2SO4. Another one, let's say we have magnesium triosocarbonate 4. MgCO3, magnesium tricarbonate 4. This one is sodium tetraoxosulfate 6. Let's see how you can calculate their relative molecular mass of each. So the first thing you need to first know their atomic mass of each element in that compound. For instance now, to do that, let's write atomic mass of each. Atomic mass of sodium is 23, sulfur is 32, and oxygen is 16. So we need to know the atomic mass of each before we can get their molecular mass. So for sodium now, for the first one, Na2SO4. So, and if you look at this compound, we have 2 atoms of sodium, 1 atom of sulfur, and 4 atoms of oxygen. So how do we now get the relative molecular mass? So let's add. Here we are going to hit 2 into Na, that is 2 into 23. 223 because I have 2 atoms of sodium. I can say 2 into bracket. It means 2 times atoms of sodium plus, for sulfur you have only 1, that is 32, plus here you have 4 atoms of what? Of oxygen. So it's going to be 4 into 16. That is 4 times 16. And when you do that, that is 2 times 23. You can say 2 times 23. 2 times 23 plus 32 plus 4 times 16. So here we have 46 plus 32 plus 4 times, I think this one is 64. So if you add everything together, 46 plus 32 plus 64, I think this one is 12. 12, I think this one is 42. So it's going to give us 142 grams per mole. That's the unit of what? Of relative molecular mass. So every number of this, consider what we are saying here, that is sum of relative atomic masses. So I'm adding atomic masses of what? Of each atom. So giving us what? Relative molecular mass. Okay, let's look at the second one. Let's calculate the relative molecular mass of magnesium triosocarbonate 4. Magnesium carbonate 4. So Mg CO3. So we are going to have, here we have just one. What's my atomic mass of magnesium? Atomic mass of magnesium. Magnesium is 24. Atomic mass of magnesium is 24. So it's going to be 24 plus carbon is 12. I have carbon too. Carbon is 12. So C here is going to be 12. O here is 16. That is 16 multiplied by 3. So here we are going to have 24 plus 12 plus 16 times 3, that is 48. We are going to have 48. 12 plus 48, that is 60. 60 plus 24, that is 84. Our final answer will be 84 grams per mole. So that is this gram per mole. This is what we call what? Relative molecular mass. So to get the relative molecular mass, substitute each atomic mass and multiply by number of atoms attached to them and add it together. It will give you what? Relative molecular mass. give us relative molecular mass. So that's how to calculate relative molecular mass of any compound. Relative molecular mass of any compound. Before we leave that, you can be asked, so how